Effect of dielectric on capacitance. When the space between the two plates of the capacitor is filled with a dielectric constant K, then it sets polarized such that the surface charge densities on both the surface of dielectric are sigma p and minus sigma p as shown in the figure. The electric field intensity between the plates now can be given as E equals to sigma minus sigma p by epsilon naught equals to sigma by epsilon naught minus sigma p by epsilon naught equals to epsilon naught minus p by epsilon naught, where p is polarization density. In the face of A and an induced charge of negative q appears on inner surface of plate B. As the plates are uniform and parallel, the distribution of charge phases and hence the field will be uniform throughout the inner uniform between the plates excepting at the edges. This effect can be minimized if D is very small as compared to area A of each plate, that is, D much less than A. If sigma is the surface charge density of the plates, then the electric field intensity between the plates according to Cauve's law is E equals to sigma by epsilon naught, where sigma equals to Q by A. E equals to Q by epsilon naught A. Potential difference between the plates is V is equal to ED. V equals to QD by epsilon naught A. This, the capacitors of the capacitor, is obtained as the polarization density P of a dielectric slab is proportional to reduced volume of electric field intensity. E is expressed as P equals to psi epsilon naught E, where psi is electric susceptibility. Therefore, E equals to E naught minus psi epsilon naught E by epsilon naught. E equals to E naught minus psi E. E of 1 plus psi equals to E naught. By definition, E naught by E equals to K, or E naught equals to Ke. Therefore, E of 1 plus psi equals to Ek. K equals to 1 plus psi. For air or vacuum, psi equals to 0. Therefore, K equals to 1. Also, since E equals to E naught by K, the potential difference between the plates, V equals to ED equals to E naught by K into D equals to Q by K epsilon naught A into D. Thus, the capacitance of the capacitor is C medium equals to Q by V equals to Q by QD by K epsilon naught A. C medium equals to K epsilon naught A by D. C medium equals to K of C air. Therefore, K equals to C medium by C air. Thus, dielectric strength may be defined as ratio of capacitance of a parallel plate capacitor with dielectric between the plates to the capacitance with air between the plates. From the above equation, it can be said that capacitance of a parallel plate capacitor depends on 1. Size of the plates, 2. Distance between the plates, 3. Medium between the plates.